Okay, and finally, we are now doing the exam style questions from chapter 9. It is of the utmost importance if you are preparing for the IB exam to do these problems on your own before you see my solutions. The whole idea of this is to see if you can answer them on your own. If you can, you should be somewhat prepared for the IB exam, or at least this portion of the IB exam. If you can't, you obviously need practice. If you just look at my solutions and say, oh yeah, that makes sense. Oh yeah, I got that. That tells you nothing. Formula book, completely acceptable. Calculator is allowed for paper 1 questions, for paper 2 questions, but not for paper 1 questions. And when I look at page 423 in the book, I see that there's 1, 2, 3, 4, 5, 6 paper 1 questions and 2 paper 2 questions. So we'll make sure on the paper 1 not to use the calculator. Question 8. Paper 1. It says given A equals the 2 by 2 matrix 3, -2, 2, -3, and B equals the 2 by 2 matrix 4, 0, 1, -2. Find the following. A, it wants 2B for 2 marks. B, it wants A minus B for 2 marks. C, it wants AB for 2 marks. And D, it wants A plus B quantity squared, also for 2 marks. So we should definitely pause and do these yourself, all 4 of them, A, B, C, D, and then compare your answer to mine. So here are the solutions. A, they want 2B, no problem. A scalar times a matrix. We just multiply each entry of that matrix by 2. Done. B, A minus B, no problem. They're both the same order, so we can subtract. 3 minus 4 is -1, -2 minus 0, 2 minus 1, -3 minus -2. There's A minus B. C, AB, we're going to multiply them. Here I am going to write them out because it's much easier to determine the product when you see the matrices right next to each other. 2 by 2 by 2 by 2 gives me a 2 by 2. First one, 3 times 4 is 12, minus 2 is 10, 0 plus 4, 8 minus 3, and 0 plus 6. So AB is 10, 4, 5, 6. And then finally, they want A plus B quantity squared. So first, I'm going to add A and B, giving me 7, -2, 3, -5. And then I'm going to square that, which means multiply it by itself. 2 by 2 by 2 by 2. 49 minus 6 is 43. -14 plus 10 is -4. 21 minus 15 is 6. And -6 plus 25 is 19. So that takes me to the end of question 1. That was a total of 8 marks. So I'm going to write here, this question was an 8-mark question. At the end of the chapter review of the exam style questions, you can calculate your score and kind of get an indication of where in the scale from 1 to 7 you're going to fall. Question number 9, also a paper 1 question, so no calculators are allowed. It says the matrix A is again a 2 by 2 matrix, x, -1, 4, and 3 minus x. It's singular. So in order to answer this question, you better remember what singular means. It says determine the possible value or values for x. Determine the possible value or values for x. When I look on the formula book, they do not define singular matrix. We certainly did, I recall. It's in the book. But again, pause, try to do this yourself. Even if you don't recall what singular means, maybe you can just guess and come up with something. So singular matrix means that there's no inverse. It's a square matrix with no inverse. No inverse means that the determinant is 0. So taking the determinant, I get x times 3 minus x minus negative 4 equals 0. 3x minus x squared plus 4 equal to 0. That's the same thing as saying x squared minus 3x minus 4 is equal to 0, which I can factor into x minus 4. X plus 1 is equal to 0. So my solutions are negative 1 and 4. And those are the two values of x that make a singular. This one was a 5-mark question. And that takes us to the end of question number 9. Of course, the only problem with this idea of calculating your score is you got to know how partial credits is assigned. So it'll be more like a worst case scenario. Like if you get it right, give yourself full credit. If you get it wrong, give yourself no credit. We'll see where you fall. And you can kind of have a worst case scenario idea. Question 10. Also paper 1, so no calculator. We're given the matrix P is 1/2 negative square root of 3 over 2 positive square root of 3 over 2, 1/2. And the matrix Q, also 2 by 2, is root 3 over 2, 1/2, negative 1/2, root 3 over 2. So part A, it says find the matrix PQ to the 3rd power. That's 3 marks. And part B, it says hence. Hence, in the language of the IB, means using the information that you just found in the previous steps, conclude or find whatever comes next. You can't just do it a different way. Hence, if it doesn't care how you do it, it would say hence or otherwise. Either hence, in other words, from this information, or some other method. But either way, it says find the smallest value of n such that PQ to the nth power is the matrix negative 1, 0, 0, negative 1. And that's for 2 marks, which means they're claiming that part B is easier than part A. Sometimes you can tell by how many marks, how complicated of a question it is. All right, so definitely pause, try to do this. Okay, so A, let's first find PQ. Oh, that's not what I wanted to do. Oh, cool. Anyways, PQ is P, which is 1/2 negative root 3 over 2 positive root 3 over 2 1/2 times Q, which is root 3 over 2 1/2 negative 1/2 root 3 over 2. So what is this equal to? 2 by 2 by 2 by 2 gives me a 2 by 2. First one is root 3 over 4 plus another root 3 over 4 gives me a root 3 over 2. Next one is 1 over 4 minus 3 over 4, negative 2 over 4, that's negative 1/2. Next is 3/4 minus 1/4, 2/4 is positive 1/2. And next one is a root 3 over 4 plus root 3 over 4 is root 3 over 2. So that's what PQ is. And now they want us to find PQ to the 3rd power. So let's first find PQ squared, which is root 3 over 2 negative 1/2 1/2 root 3 over 2 times root 3 over 2 negative 1/2 1/2 root 3 over 2. And by the way, looking at your formula sheet, I mean, this is certainly the most direct way of doing it, but looking at your formula sheet, I'm inclined to think that there's a trick here, which we will talk about. Actually, yes, there's certainly a trick here. I see it right away. And if you don't see it, then you can, of course, do it the way that we're doing it. But what I see is on the formula sheet, I look at the anti-clockwise, counterclockwise rotation of angle theta, cosine theta, negative sine theta, cosine theta. And I look at this matrix PQ, and I realize we got positive, negative, negative, positive, where those two are the same magnitude, and those two are the same magnitude. So PQ is a counterclockwise rotation of angle 30 degrees. Counterclockwise by 30 degrees, which means if we counterclockwise 3 times, if we take it to the third power, that should be a 90-degree rotation. And in fact, let's just show that that's the case. This is, of course, not the easiest way of doing this now that we have this trick, but if you don't see the trick, we should do it this way. 3/4 minus 1/4 is 2/4 or 1/2. Negative root 3 over 2, sorry, negative root 3 over 4 minus root 3 over 4 is negative root 3 over 2. Root 3 over 4 plus root 3 over 4 is root 3 over 2. And negative 1/4 plus 3/4, 2/4 is 1/2. So PQ quantity squared is actually the same thing as P. So therefore, PQ to the third power is, well, that's just an observation, but it's PQ squared times PQ again. So if I take PQ squared, which I just found, and I multiply it by PQ, which is in the top right, root 3 over 2, negative 1/2, 1/2, root 3 over 2. So this gives me root 3 over 4 minus root 3 over 4 is 0. Negative 1/4 minus 3/4, negative 4/4, negative 1. Root 3, sorry, 3/4 plus 1/4 is 1. And negative root 3 over 4 plus root 3 over 4 is 0. So it gives me PQ to the third is that. Which, again, you'll hopefully notice is a rotation of 90 degrees. Cosine 90 is 0, negative sine of 90 is negative 1, sine of 90 is 1, cosine of 90 is 0. For part B, it says, hence, find the smallest value of n such that PQ to the n equals negative 1, 0, 0, negative 1. Well, if you take 0, negative 1, 1, 0, and you multiply it by itself, you get negative 1, 0, 0, negative 1. So that's PQ cubed times PQ cubed, which is the same thing as PQ to the 6th power. So therefore, you get n is equal to 6. How do I know that there's no a smaller number? Well, for 2 reasons. One, if you recognize that this is a rotation problem, the negative 1, 0, 0, negative 1, we know is a reflection over the y-axis, which is rotating by 180 degrees. So if each PQ is 30 degrees, then 6 PQs gives you 180 degrees, you get n equals 6. It does say hence, though. So the other way I'm thinking about it is once you have PQ to the third, which is 0, negative 1, 1, 0, you can multiply that by PQ again, and then by PQ again, and you'll see that neither of them give you negative 1, 0, 0, negative 1. Therefore, 6 is in fact the smallest value of n that gets it to you. So there's the conceptual way of getting it in terms of recognizing the rotations. And then there's the brute force plug and chug, which at the end of the day is perfectly acceptable as well in getting you the right answer. So that question was 5 marks. Question 10 was again 5 marks. All right, moving on to question number 11. This is a paper 2 question. Doesn't mean it's harder, although it most likely is. It just means that you are allowed to use your calculator. So it gives me the matrix A, which is 4, 1, 3, 6. And then this is part A. It says show A satisfies A squared minus 10A plus 21I equals 0. I, of course, is the identity matrix, and 0 is the 0 matrix. So show that it satisfies that. Then it says, hence, express A cubed in the form of some constant times A plus some constant times the identity. C, hence, express A to the 4 in the form of some constant times A plus some constant times the identity. This is a 10-mark question. Okay, so this one is more challenging. And certainly, unlike the previous 2 problems or the previous 3 problems, we've done nothing like this in this chapter. So this is a real good IB question in the sense of, okay, here's all the stuff that you've learned. Now, take it to the next level. So pause and try yourself. Okay, so first part A, show that it satisfies that. That part's easy. We want to show that 4136 squared, or 4136 times 4136, minus 10 times 4136, plus 21 times the identity matrix. We want to show that this is equal to the 0 matrix. Well, let's see if it is. This becomes 16 plus 3, that's 19, and then 4 plus 6 is 10. 12 plus 18 is what, 30, and 3 plus 36 is 39, minus 40, 10, 30, 60, plus 21, 0, 0, 21. So 19 minus 40, negative 21 plus 21 is 0. 10 minus 10 plus 0 is 0. 30 minus 0 plus 0 is 0. 39 minus 60 is negative 21 plus 21 is 0. So yes, this is in fact equal to the 0 matrix. Not the 0 number, but the 0 matrix, which is the matrix all of whose elements are themselves 0. Now, part B, hence, we want to show that A cubed can be written in the form of PA plus QI. Well, what is A cubed? A cubed is A squared times A. And what is A squared? Well, if A squared minus 10A plus 21I equals 0, A squared itself is 10A minus 21I. So we have A cubed is the same thing as 10A minus 21I times A, which when I distribute gives me 10A squared minus 21A. Well, I can't have any A squareds, so let's again replace A squared with 10A minus 21I, giving me 100A minus 210I minus 21I, or 100A minus 231I. So we have now written A cubed in the form of P times A plus Q times I. C, hence, do the same thing with A to the 4th. Well, A to the 4th is A cubed times A, And we just established that A cubed is 100A minus 231I, which when I distribute gives me 100A squared minus 231A. What is A squared? Well, it's still 10A minus 21I, and this is minus 231A. So we get 1000A minus 2100I minus 231A, which becomes I made a mistake in the previous one. Looking back, 10A squared minus 21, not 21A, but 21, not 21I, but 21A. I got to go back and fix these. Hopefully you caught them and you were like, what's this guy doing? Let's fix these. So 100A minus 21A at 79A minus 210I. So that's my P and my Q. So A to the fourth is A cubed, which we just established to be 79A minus 210I times A. Well, let's just erase all of this and redo it. So I get 79A squared minus 210A. What is A squared? Well, it's still 10A minus 21I minus 210A. So that's 790A minus, this is a calculator problem, so 79 times 21 is minus 1659I minus 210A. And then before we get 580A minus 1659I. And that takes us to the end of question number 11. By the way, this property here, the fact that A satisfies this equation, this is not a coincidence. Something in advanced linear algebra or advanced math, but basic linear algebra called the Kaylee-Hamilton theorem. And that's what where this comes from. Okay, very, very, Kaylee-Hamilton theorem, very important theorem. All right, question number 12. This is again paper 1, so no calculator. Calculator goes away. And we have the 3x3 matrix. A equals 3, 2, negative 1, 0, 1, 2, 1, 1, 3. And the matrix B, another 3x3 matrix, 1, 0, 1, 0, 1, 0, 1, 0, 1, kind of a cool looking matrix. Part A says, find A inverse. Well, and that's strange that it would ask you that. I'm going to pause in a second and I'll tell you why it's strange. Because they were very specific that finding inverses of matrices is for 2x2, you do it by hand. We have a formula, but for 3x3, use a calculator. And this is a 3x3, but it says paper 1. So let me pause and check to see if they think that's a typo. So apparently it's not. Or at least nobody's recognized it as being a typo. I still think it is, but just in case it's not, let me show you the method for finding the inverse of a 3x3 matrix. Actually, you know what? The method is kind of tough. I'm going to assume it's a typo, and let's just find it on the calculator. So we're going to switch this to a paper 2. Find A inverse. That's part A. And then B, it says hence. Hence, find C, matrix C, such that AC is equal to B. And this problem is 5 marks. Okay, so use a calculator for part A, but not for part B. Let's compromise and go ahead and solve that. Pause and do your thing. So first, let's find A inverse. So on my calculator, edit a 3x3 matrix. 3, 2, -1, 0, 1, 2, 1, 1, 3, and then inverse it. I get a lot of decimals, so I'm going to math, enter, enter. So A inverse equals 1/8, -7/8, 5/8, 1/4, 5/4, -3/4, -1/8, -1/8, 3/8. B. Hence, find C. Well, if you start with AC equals B and you multiply on the left by A inverse, you get C equals A inverse B. So let's take this matrix and duplicate it. That's my C inverse. And then let's take this matrix here and duplicate it times that. Let's make this bigger. Okay. So what do we get? What is C? 1/8 plus 5/8 is 6/8. That's 3/4. Next one is -7/8. All these ones make this kind of easy. And then 1/8 plus 5/8 again is 3/4. So a lot of copies there. Next one, 1/4 minus 3/4, -2/4, -1/2, 5/4, -1/2 again. And then -1/8 plus 3/8 is 2/8, which is 1/4, -1/8, and then 1/4 again. So a lot of nice simplification based upon the B matrix. Okay. Question 13. Again, they say this is a paper 1. Let's see if they lied this time. Okay, but paper 1. It says, excuse me, it says consider the following system of equations. 5x plus 3z equals 23. X minus 2y plus 5z equals 23. And 3y plus 7z is equal to 122. A, write a system in the form. So write in the form AX equals B. B, find A inverse. And C, hence, solve the system. So again, it's a 3x3 situation. So use your calculator to find A inverse, even though they say it's a paper 1. So pause it and then go ahead and do that. Okay, so A. First, let's write in the right form. So first I'm going to rewrite the, no, it's already written in the right. Okay, so I'm going to go right to it. 5x, no y's, 3z's. 1x, -2y's, 5z's. No x, 3y's, 7z's. Times the currently unknown x, y, z in that order equals the three numbers 23, 23, 122. B, find A inverse. Okay, well, 3x3, so that's a calculator problem. Let's edit a 3x3 matrix, giving me 5, 0, 3, 1, -2, 5, 0, 3, 7. And then take that one and find the inverse. Ooh, lots of decimals. What's math, math? Ooh, we get nice fractions. A inverse. 29 over 136. -9 over 136. -3 over 68. 7 over 136. -35 over 136. 11 over 68. -3 over 136. 15 over 136. And 5 over 68. By the way, it's not hard finding the inverse of a 3x3 matrix, but you do have to, you got to learn it. It's called Gaussian elimination, or the Gauss-Jordan method. There's multiple ways of doing it. But calculator, of course, nothing beats that. Hence, solve the system. Well, if AX equals B, then X equals A inverse B. We already have A inverse, so let's go ahead and edit a 3x1 matrix B, 23, 23, 122. and then take the matrix that I just found, the inverse, and multiply it by b. And that gives me the matrix -2, 15, 11. As a result, x equals -2, y equals 15, z is equal to 11. If after all of that, you get nice numbers as your answers, as opposed to decimals that go on forever, you probably did it correct. And this one was 7 marks. And now we go to question 14. Only 2 questions left. And notice that they haven't asked us anything about probability or about eigenvalues and eigenvectors yet. Now I see an eigenvalue one coming. That's the next question, but they completely skipped all probability. So obviously this exam doesn't cover everything. You can't just say, oh yeah, I did amazing on the exam, therefore I'll do fine. You got to make sure you know everything. Question 14, paper 1. At a particular opening night screening of Galaxy Wars 2, one cinema, here's my one cinema, had a full attendance of 750 people. It charges £8 for adults. It charges £5 per child, and it charges £4 for OAPs. I have no idea what an OAP is. I can certainly pause and check, but I just don't care. Now, the number of OAPs attending was 1/5 of the total attendance. So the number of OAPs was 1/5 of total attendance. The total amount received, was 4,860 pounds. Use a matrix method. Doesn't just say get the answer. It says use a matrix method. And by the way, this is 9 marks. It says use a matrix method to determine the number of children. Number of children is equal to what? Don't just get the answer. Use a matrix method to get the answer. So go ahead and pause it and do your best. Okay, so let's see what we have here. So there's 3 unknowns here. X equals number of adults. Y equals number of children. Z equals number of OAPs. We have 3 unknowns. So if I want to use the matrix method, I better have 3 equations. Well, let's see what I have here. 750 people. So if I take the number of adults plus number of children plus number of OAPs, that has to equal 750. The number of OAPs was 1/5 of the total attendance. So Z is 1/5 of 750, which is just 150. Yeah, that was a nice simplification. And the total received was 4,860 pounds. So if there's X adults and each adult gave me 8 pounds, I make 8X pounds from all the adults. I make 5Y pounds from all the children. I make 4Z pounds from all of the OAPs, and that has to equal 4,860. Now, personally, since they gave me Z straight up, I might as well employ it and get X plus Y equals 600. Because if Z is 150, I can subtract that off. And 8X plus 5Y equals what, 4,260? Because 4Z is 600, yeah. Now, I didn't use matrix methods. You might say, hey, they said use matrix methods. No problem, I'll use a matrix method now. They didn't say use it for everything, they just said use one. So 1X, 1Y, 8X, 5Y, acting on X, Y in that order, gives me 642.60. This is a 2 by 2, and it's paper 1. So I can multiply on the left by the inverse. The inverse is 5 and 1 flip, -1 and -8 negate. And then 5 minus 8 divided by -3, 642.60. So let's see what I get. 3,000 minus 42.60 is -12.60. And -4,800 plus 42.60 is 540 over -3. So I get 420, and I get, what is that, 180. And since y is the number of children, there are 180 children. Used matrix methods, just first simplified a little so that the math was a little easier. And then finally, the last one is question number 15. This is a paper 2 question. A is equal to the matrix 4, -2, -2, 4. A, find the eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors. B, find P and D such that D equals P inverse AP. And then C, find an expression for a to the n. And this is a total of 14 marks. So go ahead, pause it, try to solve it. Hopefully you had no problems. We did lots of examples of eigenvectors. The first thing we do is we subtract lambda along the main diagonal and only along the main diagonal. Then we take its determinant, which is 4 minus lambda, 4 minus lambda minus 4 is equal to 0. In other words, 4 minus lambda squared is equal to 4. So that 4 minus lambda is plus or minus 2. So that lambda equals 4 plus or minus 2. In other words, we have 2 or 6 as my eigenvalues. Then for each eigenvalue, we are going to find its corresponding eigenvector. How do we do that? Well, if I plug in 2, I get 2, -2, -2, 2, acting on the currently unknown xy gives me 0, 0. 2x minus 2y equals 0. The same thing as x minus y is equal to 0. What's the simplest vector that fits that equation? 1, 1. Other one, if I plug in 6, I get -2, -2, -2, -2, acting on xy is equal to 0, 0. So that's -2x minus 2y is equal to 0, or x plus y is equal to 0. So the simplest one for that one is 1, -1. So I have my eigenvalue, eigenvector pairs. 2 with the eigenvector 1, 1. And this should be example, this should be A. And 6 with 1, -1. So hence, find the matrix P. Well, the matrix P is the matrix of eigenvectors, where D is the matrix of eigenvalues in the appropriate order, 2 before 6. And this says find the matrix P and D that satisfies D equals P inverse AP, and we found them. And then C, find a general expression for a to the n. Well, A is the same thing as PD P inverse to the n, which is P D to the n P inverse. So P is 1, 1, 1, -1. D to the n is 2 to the n, 0, 0, 6 to the n. And then P inverse, we switch those, we negate those, and then we divide by the determinant, which is -1 minus 1, which is -2. So what do we get here? We get 2 to the n 2 to the n, 6 to the n, negative 6 to the n, times negative 1, negative 1, negative 1, 1 with the constant negative 1/2. Actually, because it's negative 1/2, I will factor that negative in and change all the signs and just multiply it by positive 1/2. And then what do I get here? I get 2 to the n plus 6 to the n, 2 to the n minus 6 to the n, 2 to the n minus 6 to the n, and 2 to the n plus 6 to the n, all times 1/2. So what's my final answer? It's 2 to the n plus 6 to the n over 2, 2 to the n minus 6 to the n over 2, 2 to the n minus 6 to the n over 2, and 2 to the n plus 6 to the n over 2. And that takes us to the end of chapter 9. Next video, well, I'm not sure what order you're going in, but we have finished chapter 9 on modeling with matrices. The only section in the book that uses matrices after this is chapter 15 on graph theory, which is the next videos that I'll be recording. So perhaps you're going to move into chapter 10 next. I don't know. But either way, I hope you learned a lot. I hope it made sense. And I'll hopefully see you soon.